Hi guys, I'm Nancy, and I'm going to show you how to integrate with U-substitution. What is U-substitution? Well, sometimes you can't integrate right away, and you have to change the integral to make it easier to integrate. So you have to clean it up a little bit by substituting with U. So I'll show you how to do that. Let's take a look at a few. All right, here are all the types of problems I'm going to show you using U-substitution. The first example is the most basic kind. It's a neat, tidy U-substitution problem, and it has a power rule in it. The second example has a fraction and a square root, and you'll have to manipulate or rearrange the du expression to get what you need to integrate easily. In this case, you'll have to divide by a number and divide by a negative in your du. The third example has a square root in it, and you'll have to manipulate the u expression, rearrange the u expression by subtracting a number in it in order to integrate easily. And the final type has trig functions in it, and it's a fraction, and you'll have to rearrange your du expression to integrate easily. All right, so let's look at the first one. All right, here's a simple example. Now looking at this, I don't really know offhand how to integrate that directly, but I can use a trick called U-substitution. Why is it called U-substitution? Well, no good reason as far as I know. They could have used any letter, but it's U, that's the standard, so we'll do U-substitution. And what that means is that you're going to rewrite this whole integral in terms of the variable u, a new variable u. The first step is to pick your u expression. To pick your u expression, a good rule of thumb is that it's almost always the longer x expression that appears in the integral, and the one that's inside some other function, inside some other form, like inside a power, inside a square root, inside the bottom of a fraction. What will always be true to use U-substitution is that the integral will have some function, and the other part will be the derivative of that function. So notice that the derivative of x cubed plus 5 is just 3x squared. So you know that your u should be what's inside the parentheses here. Your u should be x cubed plus 5. So go ahead and write that off to the side. You define your new variable u to be x cubed plus 5. So say you still don't know how to pick your u expression. Yeah, it's not obvious, it's kind of tricky. So let me show you another way of thinking about it. Okay, so look at all these forms that I drew, these function forms. You could have something to a power, e raised to something, something under a root, something in the bottom of a fraction, something in the bottom of a fraction and under a root, and something in the bottom of a fraction and raised to a power in the bottom. No matter what it is, any of these forms, the thing that is inside another function, in parentheses, is almost certainly your u expression. It's what you should define as your u equals. Okay, so you've found your u, x cubed plus 5. This is your u. The next step is to find du, the differential. Du equals. To find du, all you do is take the derivative of this side with respect to x. So as you know, what that should give you is 3x squared plus nothing, since 5 is a constant. And what you have to write at the end of your du differential is a dx, always, because you took the derivative with respect to x. Now, in a perfect world, perfect problem, your du, 3x squared dx, is exactly what's left in the integral, apart from u. And this is a simple perfect world problem, so it is. this part, 3x squared, what's left, 3x squared dx, is exactly your du. What this means is that you're ready to substitute and get everything completely in terms of u and du. So let's do that. In the next line of work, you have an integral of, remember, in place of x cubed plus 5, you're writing u. So it's u to the 7th power. And in place of 3x squared dx, you're writing simply du, because what's left after you take that away is just 3x squared dx. So you put in place of that du. The du always goes at the end of your integral, not in the front. So this is now your integral all in terms of u du. This should look like something you know how to integrate because it's just a variable raised to a power. You use the power rule. If you don't remember how to do that, the pattern is to raise this power by 1, so it becomes u to the 8th, and divide by that new power, 8. And since this is an indefinite integral, indefinite antiderivative, meaning there are no limits, you have to write at the end plus c. Don't forget that. Plus c. All right, you've integrated. What happened to the du? It does just disappear when you integrate. When the integral sign, the integral symbol, goes away, so does the du. You can think of it as undoing the chain rule, the inverse of the chain rule. The du just drops out, it goes away. Now, you've integrated, you've evaluated that integral, but what you were originally given was in terms of x, not u. So there's another step where you have to back substitute and plug in for what u originally was. Notice that your U-substitution made it very easy to integrate. That was the whole point of substituting. But now in this final step, in place of u, you want to back substitute. Put in for u what you defined it to be, x cubed plus 5. So we have x cubed plus 5 to the 8th power. It's all to the 8th power over 8 plus c. So that is your final answer for the integral. Sometimes when you pick a u expression, the du, the derivative you get, does not give you exactly what you need to integrate right away. Then what you have to do is manipulate the du or the u, rearrange it so you have exactly what you need to make the substitution work out. So let's try this example. Start the same way. You need to pick your u and pick it wisely. Think back to what I said about the forms. U is usually the longer x expression that's inside another function form. So a good choice would be 1 minus x to the 4th. So right off to the side, u equals 1 minus x to the 4th. If you're wrong, you can always go back and pick a different u. But try to pick your best, what you think is the best option. Next step is to find the differential du. Du you get by taking the derivative of this expression with respect to x. So the derivative of the 1 gives you nothing, and then this part, the derivative would be negative 4x cubed dx. Don't forget the dx. That's there because you took the derivative with respect to x. Okay, ideally, in a perfect world, this du that you found would match exactly what you have left over in your integral, x cubed dx. Unfortunately, it doesn't. You have this -4 there that you don't want. Your job is to make it match up so that you can plug in here and get everything in terms of u and du. All you need to do is get rid of the number that you don't want. You don't want the negative sign or the 4, so divide out -4 from both sides. And what you have left over is what you want, just x cubed dx on one side. And on the other side, you have -1/4 du. Now you're ready to do the next step, to substitute everything in terms of u and du. So let's rewrite that. In the next line of work, you'll have equals integral. In place of 1 minus x to the 4th, you have just u. So in the bottom, you have a square root of u. And then in place of x cubed dx, in place of x cubed dx, you're going to put in -1/4 du. And you can just write that on the top for now, -1/4 du. You don't need the dx anymore. You have a du now because everything in this integral is written in terms of u and du. That's good. That's what you want because it will be easier for you to integrate now. Let's do some simplifying. In the next line, go ahead and pull that constant, the -1/4 out front, -1/4 integral. Any number, including the negative sign, can be pulled out front and it will be easier to see how to integrate. Leave the du at the end, as you normally do. So you just have 1, nothing but 1 on top. On the bottom you have a square root of u. This is more and more looking like something you know how to integrate. Let's make it a little clearer, even more clear. So you have -1/4 integral 1 over square root of u is 1 over u to the 1/2 power. The square root of a variable can also be written as variable to the 1/2 power. Du. Now since you know how to take the integral of a power, most likely, what we want to do is bring this fractional power up to the top. When you bring a power up to the top of a fraction, you have to make the power negative. So what you have is -1/4 integral of u to the -1/2 power du. Just remember, when you bring a power up to the top of the fraction, it becomes negative. This negative power means 1 over u to the 1/2 power. Anyway, now you're really ready to integrate. All that work of doing U-substitution was so that you can get to this point and integrate. So when you integrate that, you get -1/4. And you're going to raise the power by 1. This is the power rule. When you add 1 to -1/2, it's the same as adding 2 over 2. So you end up with +1/2. Anyway, when you raise u to the -1/2 power by 1, you get u to the +1/2 power. Then, by the power rule, you need to divide by the power you just raised it to, the number you just raised it to. So you divide by 1/2. Now, When the integral goes away, when you integrate, when this integral symbol goes away, the du goes away. And since it's indefinite, no limits, you must write plus c. Don't forget that. Now do some basic simplifying. And you have, because you're dividing by 1/2, it's the same as multiplying by 2. So you have -1/4 times 2, u to the 1/2 plus c. And that simplifies to -1/2. But in place of u, remember you need to back substitute. Put back the original x expression that you set u equal to. So in place of u now, since you're toward the end, you're going to write 1 minus x to the 4th. That is all raised. All of that is raised to the positive 1/2 power. And plus c. You might wonder why the c doesn't have a -1/4 multiplied by it. The reason is that even if you did multiply the c by -1/4, it wouldn't matter because c right now doesn't have any meaning. It doesn't have any value. We don't know what it is yet. It's an indefinite integral. So even if you change c, you could still relabel it as a new c. So you don't need to multiply the c by a number. You can just write plus c at the end. And your answer, your final answer for this integral is -1/2 times 1 minus x to the 4th raised to the 1/2 power plus c. And you're done. Okay, here's another one where the u that you pick doesn't give you exactly what you need. And in this problem, you're actually going to have to rearrange the u expression to make the substitution work. The first step is still to pick your u expression. Pick wisely. The best choice is usually the longer x expression that's inside something. So a good choice would be u equals x plus 2, since it's underneath the radical. Find your differential, du. Your differential is dx because the derivative of this is 1 dx and nothing from the constant 2. So you can just write dx. Now, check to see if you can replace everything in terms of u and du. That's always your goal in U-substitution. You can replace this with u. Here, this is your u. And your du can replace dx, but you haven't found a way to replace x. You need to find a way to eliminate that. How do you do that? Well, the only way is to manipulate your u expression. Rearrange it somehow to get x alone so that you can plug in for u. So you want to rearrange that expression. Do it down here. You can subtract 2 from both sides to get x alone. So that gives you x equals u minus 2. Now you can substitute everything to be in terms of u and du. So now you've plugged in u minus 2 for x and u for x plus 2 and du in place of dx. So now everything is in terms of u and du, so you can integrate. It will be easier for you to rewrite this root as a power of 1/2. It will also make it easier if you multiply this out, if you distribute this. U times u to the 1/2, -2 times u to the 1/2. So that gives you This power is 3/2 because this was u to the first times u to the 1/2. What you have to do is add those exponents. When you add 1 plus 1/2, you get, with a common denominator, 2/2 plus 1/2, which is 3/2. So this is 3/2, and this is just minus 2 u to the 1/2 power. Now you're actually ready to integrate, and you can use the power rule to integrate these two terms. When you integrate, you get u to the 5/2 power divided by 5/2. Remember, with the power rule, you raise the power by 1 and divide by that new number. Why is it 5/2? Because 3/2 plus 1, if you do that math and get a common denominator, is 3/2 plus 2/2, which is 5/2. 5/2, and you divide by the new power. Don't forget that. Same thing for u to the 1/2. When you integrate that, you have to add 1 to 1/2. And that gives you 3/2 because 1 plus 1/2, 1/2 raised by 1, is 1/2 plus 2/2, which is 3/2, and divided by 3/2. Okay, you can simplify this because dividing by a fraction is the same as multiplying by its reciprocal. And this is what you get when you simplify. Don't forget to put your plus c here, since it's an indefinite integral. Also, the du, when you integrated, the du just disappeared. When you integrated and got rid of the integral symbol, the du goes away. All right, there's one more step, which is to back substitute for u. You don't want to leave u's in your final answer. You've done all the work of u substituting. Now, get your x's back in the expression. So you need to plug in for u, x plus 2, everywhere u appears. And this is your final answer. Okay, so you've seen a lot of examples and you get the basic gist of this. But what happens if you have a trig function? Let me quickly show you what happens then. First of all, if you get something like this that has a square or a cube inside the trig function, it's much easier to see what to do next if you rewrite this with parentheses. This is sort of silly notation, I know. What that looks like is, so this cosine cubed x is the same as cosine x all cubed, all raised to the 3rd power. This is much easier to see what to do in U-substitution. Just pick your u expression next, and the best choice is usually what's inside the power. So u can be equal to cosine x. Now find your du differential. When you take the derivative of cosine, you get negative sign. So your du is negative sine x dx. Now check to see if you can replace everything in terms of u and du here. This is your u inside the cube power in the bottom. Your du is negative sine x dx, and you have positive sine x dx. So you're very close with just a negative sign difference. All you need to do is get rid of this negative sign and move it to the left by dividing by -1. Okay, so you have sine x dx equals negative du. Now replace everything in terms of u and du and integrate. Okay, so when you replaced everything in terms of u and du and you integrate, this negative can come out front, and you're just going to use the power rule, which means you want to raise the -3 power by 1 and divide by that new number. When you take -3 and raise it by 1, add 1, you get -2, so that's your new power. And then you also divide by that new number, divide by -2. Don't forget your plus c when you integrate. Then you can simplify this. It's considered simpler to change the negative power, u to the negative 2, into a positive power by bringing it down into the denominator. So you have 1 over 2 u squared plus c, and then back substitute. Plug in cosine x for your u, and that's your final answer. I hope this video helps you understand how to do U-substitution. Calculus is everyone's favorite. It's okay. You don't have to like math, but you can like my video. So if you did, please click like or subscribe.